So hello at Joshua _ Ayomi. How are you doing? So you brought this question. You have a perfectly insulated box with a partition in the middle. One side is filled with an ideal gas and the other side is a vacuum. If you suddenly remove the partition, the gas will expand to fill the whole space. And the other of your question also says that the temperature is involved. So let me give you a diagram. Let's just say this is the box, and then it's perfectly, they said the word, there's a word here, perfectly insulated. So this is the insulation. So they said this is it, this is the box, right? So that means air is not going into here. An insulated material does not exchange air or any other particles from the surrounding. This is the surrounding. Now they said, okay, you have a perfectly insulated box with a partition. This is the partition. We're taking it little by little. With a partition in the middle. This is the partition in the middle. One side is filled with an ideal gas. This is an ideal gas. Ideal gas, right? So this side is filled with the ideal gas, and an ideal gas is an adiabatic system. Yeah. So temperature is constant. Work done is 0 in an ideal gas, and then internal energy is actually still 0. Then and the other side is a vacuum, empty space, work done 0, and internal energy is 0. Heat is actually 0 in a vacuum. Nothing goes on in a vacuum, right? So now if you suddenly remove the partition, the gas will expand freely. So this process is called what? The free expansion. So when we remove this, whatever we have here will move to this place immediately. Now there are two things. There's something that happens here. Number one, the movement has caused something called the entropy. And now they said entropy is the degree of what? Disorderliness of a system. Because it moved there, when it was first of all packed in one side, there was arrangement, right? But when it moved, entropy has now increased. Entropy has increased. It's now disordered. And then now you talk about pressure. There's a pressure from here moving here, but there was no external pressure reaching it, so it's still the same pressure. Then pressure is present. Now temperature, of course, there's no temperature coming from the surrounding. The temperature is still within. So the internal energy in it is actually 0. Internal energy is equal to 0. Now the heat, number 4, the heat Q is equal to 0. Now if we use thermodynamics second law, the U equal to heat minus work done. Work done already is 0. Then you move it like this, the T, change in temperature, becomes 0 because work done here is -0 minus 0. There is no work done, there is no heat. The internal energy of an adiabatic system is NT. This is the internal energy of an adiabatic system. And in an adiabatic system, it is actually a closed system. Nothing is going on, everything is constant, nothing is exchanging from the surrounding. Even with the temperature here remains the same because there's no external temperature coming in. No work done, just a spread. And what happens here was what? Free expansion. Thank you so much. Subscribe to the YouTube channel, share to your friends and family. Thank you.